Hi, in this second video I will discuss on NFA, non-deterministic finite automata. As the name says, it is non-determined, it is not sure, it is not certain. In the last video I missed the definition of deterministic finite automata. The basic definition of DFA is single transition for single input. It should be at the fingertip. What is DFA? Single transition, single input. What is NFA? Multiple transition for single input. It should be at the fingertip. What is DFA? Single transition, single input. What is NFA? Multiple transition for single input. Let's look at an example. Consider an automata or a machine in state A. When you give as a single input, that is, when you give a single input, it goes to state B. It is certain. If you give A as an input, it goes to state B. It is sure. It is certain. It is pakka. In case of non-deterministic finite automata, if you give A as input, it is confused. It is not certain. Like, it may go to state A or state C because it has both A as an input. This is non-deterministic finite automata. It is multiple transition for single input NFA, single transition for single input DFA. It should be at the fingertip. This is the difference between NFA and DFA. Now let me take example of textbook, because as you also read textbook, it may help you. First, disadvantages of DFA. Disadvantages of DFA is constructing of DFA is difficult. To construct DFA, it is very difficult. In DFA, we cannot guess. You read it. Instead of telling better, you could read it. Why NFA? Why NFA? You read it. It is not so difficult. Take this example. In start state, that is Q0. When given as A as an input, it goes to Q1. Okay, it is determined. When Q1, when we given A as input, it self loop and go for Q1, or it may go to Q2. There is a two possible chance. From Q1, it may go to Q2 since there is A, or here is another A. The arrow mark is showing here. Arrow mark is showing here starting from Q1. Okay. For A, there is confused. It may go for Q1 or either Q2. Hence, it is not determined, and hence it is non-deterministic finite automata. Similar to DFA, non-deterministic finite automata is also represented by M is equal to Q sigma delta Q0 F. As I said, Q represent number of states, sigma represents alphabet, Q0 represent initial state, F represent final state. But the only thing changes is this is mathematical modeling. Mathematical modeling of non-deterministic finite automata. Now let us discuss what is delta. As I said in last video, delta is nothing but a transition function. The difference between NFA and DFA is only delta. These four tuples own changes. The only thing changes is delta, transition. You can, I said here itself, for A, it may go here also, here also. What is changing? Only transition is changing from DFA and NFA. I hope you understood. Now let us discuss delta. In DFA, delta is transition function ranging from Q cross sigma is equal to Q. Q is state, sigma is alphabets, Q is states. I have said what is this meaning by taking an example. But here, before discussing delta, I would like to tell you about the power set. Consider a set containing A, B. It is represented by set A. Power set of A is represented by P of A. It is a set containing all the subsets of A and B, like psi, A, B, AB. Power set of A is psi, A, B, AB. All combination of this is in here. Here you can see here is 2 element, here it is 4 element. Relation is 2 power number of elements in set A. Number of elements in set A. Power set. Here is a logic. I will tell in double quote. See it with careful. I will take this example. When Q0 given A, It goes for Q1. See, here it is B. No worries. It is determined DFA like that. When in Q1, when given A, it may go to Q2 or it may stay in Q1. I would write this like Q0, no worries, when given A, go to Q1. As per this example I am writing here, it goes for Q1. When Q1 given A as input, it may go to Q2 or Q1. When Q1 given A as input, it may go to Q2 or Q1. Here, instead of writing one state, here I would represent Q2 and Q1. It is NFA. Q2 and Q1 are a member of a power set. Hence, this transition function delta ranges from Q cross sigma is equal to 2 power Q. Take this example. I will explain this. Q cross sigma is equal to 2 power Q. What is sigma? States. Q is states. What are the states? Q0, Q1. Q0, Q1, Q2. What is sigma? A. 2 power Q, it contains all element of this like psi, A, AB, B. When Q0 given A, it match something here. Q1 given A, it match something here. It is like match the following. See here, when Q0 given A, go for Q0 given A, go for Q1. Yes, same. Q0 given A, go for Q1. From Q1 given A, go to Q2 and Q1. Non-deterministic. See, when A is given, go to Q2. When A is given, it go to Q1. Two things can happen. When given A, when Q1 given A, go to Q1, Q2. When Q2 given A, go to Q1, Q2. In case here Q1, Q2 have written A and B. This is the transition function. Both are same. DFA and NFA both are same. In what is the difference is single transition, multiple transition. This is difference number 1. Difference number 2 is delta. In DFA, Q cross sigma is equal to Q. In NFA, Q cross sigma is equal to 2 power Q. That's it.